Welcome back to OMBI Anganwadi. So far, we have learned how to retrieve data using select, filter the data with the help of the where clause, and also sort the results using order by. But when working with real world data, we may often come across questions like what unique product colors are available, or what is the average salary, total sales, or what is the number of employees. So instead of looking into hundreds or thousands of rows, SQL provides features that help us in getting answers to these questions in just a single query. In this video, we will be learning two important concepts, the distinct keyword and aggregate functions. First, let us understand what is the distinct keyword and how it works. A column can sometimes contain duplicate values, but you would be interested in looking at each value only once. So that's exactly what distinct help us to do. Let's understand this with the help of some practical examples and how we can write queries for this. Like our previous videos, we will be making use of the AdventureWorks database to write all our queries and solve examples. Let's now have a look at our first example on how to use the distinct keyword. Display all unique product colors. The table is production.product. So now I'm in my SQL query window connected to the AdventureWorks database. Let's have a look at the production.product table first and look at what column we need to fetch. Select star from production.product. So we can see the color column over here. What we need is just the color column. So let's replace this star with color. And now when I execute this one, here I can see all the colors but repeating multiple times. Let's first understand the reason for this. So the reason for this being there are multiple products in the same color. So if we again look at the entire table, there is product ID 317 in black and again 318 in black, and again you can see two products in silver color. So when we just choose the column color, SQL just returns all the rows or all the values in that particular column. So that is the reason why we are seeing each color repeat multiple times. So there are a total of 504 rows in this column. When I just select the column color, the same number of rows will be returned. Yes. So to make SQL Server understand that I want to see each color only once, that is only the unique values, we have to use the distinct keyword. So the distinct keyword should be used before the column name. It will be select distinct color from production.product. Now when I execute this, you can see that each color has appeared only once. So there are a total of 10 unique records including null. Now let's take a look at our next example. Display all unique combinations of product color and size. This is actually a scenario involving the usage of distinct keyword with more than one column. So let's look at how we can solve this. Again, the source table is the same, production.product. Let's have a look at the table and how the data looks. So in any given real world scenario, I can have different products in the same color and each color can have multiple sizes. When I just pick up the color and size column, there is a chance that again I might get duplicate records because the colors and size also repeat with different products. So let's select the color and size column first without using the distinct keyword. So color comma size. So as we expected, I can see different colors and sizes also repeating each time. And we got a total of 504 rows. Now let's use the distinct keyword and look at what result set is returned. and now we have a total of 68 rows. When distinct is used with more than one column, SQL Server understands that it has to return each combination only once. So here in this case, it is a combination of color and size. So null and null is one combination. Black with null is another combination. So each color with one size is a single combination, and that single combination is returned only once. Now that we know how to retrieve unique values or unique combinations, let's have a look at another common requirement, that is aggregate functions. In many situations, we don't want to see all the rows. Instead, we want a summary of data like the count of products or count of employees or what was the average price or average sales and other similar values. So for this, SQL provides aggregate functions to calculate these kind of summaries quickly. Aggregate functions, as the name suggests, performs calculations on multiple rows and returns a single aggregate value or a summary value as a result set. And in this video, we will cover 5 of the most important and commonly used aggregate functions with the help of a few examples. The first one being count. So what count does is it returns the number of rows in a particular column. Next, coming to sum. Sum calculates the total or sum of values of a particular column. This can be used only with any numeric type of columns. Next, talking about average. Average calculates the arithmetic mean of numeric values. And lastly, talking about min and max. Min returns the smallest value of a column and max returns the largest value. These two also works with numeric data type columns. Now let's assume you are a manager and you want answers for a few quick questions like how many orders have been placed, what is the total sales amount, average order value, smallest order and largest order, for which you will have to refer the source table sales.sales order header. In this kind of a scenario, looking at the entire table across multiple rows of data will not give you the expected answers. Instead, you can make use of the aggregate functions to get these kind of summarized values. Now let's look at how we can write the query to extract the required results. First, let's have a look at the sales.sales order header table. Select star from sales order header. So these are the columns I have. To start with, how many orders have been placed? So it refers to the number or count of orders. So we will have to use the function count on sales order ID. So it would be count and within brackets sales order ID and this will give me the count or the number of orders placed. And as you can see, there is no proper column name being displayed since it's a calculated column. So to get a proper column name, I can use an alias name like number of orders. Now I can get a proper column header as well. So these kind of names are called as alias names, which help in giving customized names for each of the columns based on the user requirement. So this works either with this as keyword, say count of sales order ID as number of columns, and it also works the same without the as clause. Now going to the next scenario, what is the total sales amount? So when it comes to total sales amount, the column what we choose is total due. So here it would be the function sum of total due, and I can give the name total sales. Now this sum function tells SQL Server that the sum of all these values, 30,000 plus rows of this column total due, needs to be summed up, and this query returns the summed up value here. Also, instead of writing separate queries, you can also put all these into one query and it will be returned as a single table. Similarly, you can also get the average order value and also smallest and largest. So for the average order value, you have to make use of the average on total due, and then min and max of total due. Largest sales from this table. And now when I run this, I can get all these values in a single table in different columns. Now that you have seen that SQL not only helps in data retrieval or filtering, it also supports unique value retrieval and also performing aggregate calculations to help in answering very common business questions in just a single query. Thanks for watching and do subscribe to OMBI Anganwadi for more content on SQL.